So I'd like to take you 6 years back to a demo shown in Google I/O 2018, when the Google Assistant called a small business to book a table for a user. Let's hear it.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when? Today?
Next
Tonight?
Wednesday at 6 p.m.
Oh, actually we reserve for after 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye bye.
So with today's tech, it's become rather easy to build a similar demo, even with solutions available off the shelf. But what does it take to do this at scale, reliably, at consistently high quality? We all know the distance between an impressive demo and a solution in production remains high, especially with today's off-the-shelf tech. The technology named Google Duplex, which evolved over the last 7 years from using RNNs and streaming audio models to rely more and more on end-to-end LLMs, is used in so-and-so millions of calls per year with real people at consistently high quality across different types of applications, locations, and devices. For example, facts that we call businesses about were seen in Google Maps and search over 1 trillion times already. So we can say that the tech does work at scale. And this has been made possible thanks not just to technology, but just as importantly, several product development elements. So my name is Yoav Tzur, and since I joined Google in 2009, I've been excited about leveraging innovative technology to solve real-world problems. I lead the engineering team in Google developing the technology called Google Duplex and its user-facing applications. In this talk, I'd like to share some of these insights and lessons that we learned over the years about applying conversational AI technology at scale, especially focusing on deploying it to talk to others for you. Let's take a moment to understand our scope. What does it mean and why is it different from standard applications of conversational AI, talking to others for you? Indeed, recent years have seen tremendous progress in how easy it is to talk to machines, thanks to LLMs, how well they understand us, and how nuanced and contextual the responses are. But instead of just talking to machines ourselves, how can we use this technology to have machines talk to others for us? The appeal here is that so many real-world needs today still require real-time communication, and not for communication's sake. Calling a business to check if an item is in stock or taking messages from unknown callers. Communication, such as phone calls, is an API to the real world. And by teaching machines this protocol of human conversation, we can tap into any service aimed at humans with instant deployment at zero integration work by any remote party. For example, here are a couple of ways that we've been doing this in Google over the past years. We're calling businesses to update their local information in Google Maps regularly, conducting deep free conversations that are easy for many of them more than updating their hours themselves. The scale that they get by doing this automatically enable data freshness that simply would not have been possible with a human-powered call center, at a fraction of the cost, and at similar quality level. Facts we call about were seen by users trillions of times already. We can call businesses upon a specific user's request to find information or even complete actions like bookings. CallScreen on Pixel has a simple bot take incoming unknown calls for you to filter unwanted calls and understand what a wanted call is about before you pick it up. And we can talk to other machines for you too. For example, waiting on hold and navigating old school phone trees to get you to a live representative without hassle. So what does it take to deploy AI products and automate communication with others for you? In this talk, I'll go over 3 main areas: catering to both sides of the conversation, data acquisition and efficiency, and transparency and trust. By the way, I will not focus on the technology in this talk. As our technology stack evolves over the years, we've found most of these lessons to persevere and remain relevant regardless of implementation. Some are even more relevant in the world of available off-the-shelf technology that does reasonably well out of the box, but still takes significant work to do great and do what you really want it to consistently. When a user asks us to communicate with someone for them, it may be easy to forget that someone is also a user. We must consider their UX and success metrics too, lest they disengage and render our product useless for everyone, or undermine the health of the ecosystem. Running at scale means providing good quality for everyone every time. But if the premise is to automate communication with anyone who is just used to talking to people, how do we cater to the needs of a user who did not directly choose to use us? How do we set the right expectations? We do not have a standard user-product relationship with pre-existing expectation settings, terms of service, and fine print. How do we keep the communication efficient without being misleading? They may have just picked up the phone and just want to get on with their day effortlessly. Imagine being a receptionist in a restaurant, getting a call in a busy hour, with a lot of noise in the background and other customers waiting for you in line. What would make you engage in this conversation, or first of all, just not hang up? The first recommendation here is to leverage existing norms and practices. Be familiar, so it's easy and efficient to understand what we want without too much mental overhead. This is the main reason to sound natural and human-like. To clarify, we do not set to beat the Turing test, and not just because we always say proactively that we're automated. We try to be similar to what people know, to quickly coordinate a protocol that they're familiar with. As long as we remain easy to talk to and competent, we've seen most people happy to engage and play along. Some people even thank our bots in the end. I'd like to highlight the difference here between using an efficient communication protocol for a task and using a familiar or efficient to coordinate protocol. If we called the business to confirm their hours on Google Maps and just said, here are the hours we have, press 1 if they're correct, most would hang up before even listening to the hours. Even small differences like the voice sounding less robotic, even when saying it's automated, makes people more likely to explain themselves or help the conversation forward rather than respond laconically, giving us a chance to recover from errors since they expect us to understand free language. By showing you can talk to us as you're used to, we incur minimal mental load on the other side to understand the rules of the game and the purpose of the call. Which brings me to another good practice, which is setting the goal of the conversation clearly and early, and always calling to action to push the conversation forward. Unlike other applications of conversational AI, where the conversation itself may be part of the product, here we're trying to get something done, and this something presumably has value for both sides of the conversation. By making that value proposition clear early, and specifically clarifying that even though we're automated, the communication is done on behalf of someone who's waiting for the outcome, we differentiate ourselves from spam and other unuseful calls made in bulk, which is what many people might expect when hearing automated. Of course, in order for this to work, we need to meet the high expectations set by claiming to speak this protocol of human conversation. We can go back to the call that I played earlier for a few examples. What made this call work, in addition to being super short latency and knowing when to respond and when to stay silent and so on, is how the bot handled unexpected cases and drove it to the best possible outcome. Of course, this was a relatively simple call. Speaking this protocol of human conversation, above all, means making sense of open, free spoken language. This means being contextually efficient and clear, not repeating ourselves unnecessarily, supporting clarification questions and corrections, respecting social norms such as how much to neg the other side, and so on. And all this needs to work robustly, regardless of accents, background noise, or line quality, and various unpredicted behaviors by the other party. And the best way to be competent and determine the adequate behavior in every situation is to derive behavior as much as possible from data, not from detailed policy. Of course, we should have high-level policy, like being polite, efficient, complying with various regulations, but detailed policies like how to negotiate a time for a booking are best learned from data, not decided on a whiteboard and then implemented. Foundation models are pretty smart and knowledgeable today, and they can make good guesses about the best course of action at any point. But still, any prompt engineering, supervised fine-tuning, RLFT, is only as good as how representative its target function and data are. Seeing what actually works is the only way to guarantee good experience for both sides of the conversation, within privacy restrictions, of course. While this insight of biasing decisions by data may seem trivial, it is surprisingly common to still see product behavior defined in PRDs, flowcharts, dialogue designs, based on intuition or very few realistic examples, rather than a large enough representative and constantly updating sample of realistic product behavior. Getting good data is difficult, especially since we hold ourselves to a high standard of privacy. But don't be tempted to use it as an excuse to develop based on just intuition. Given good data, here are a few ways to derive decisions. Running experiments to see what works. We invested a lot in a very rich tool chain that allows us to browse and manage our rich corpus of conversations, as well as simulate realistically how any change to our stack or models would manifest on past changes, so decisions can very quickly consult what-if analyses that are grounded in real representative data. And finally, the best way to derive decisions from data is to just not make decisions at all and let models learn to make them directly. Deploy end-to-end models if you have good end-to-end data to evaluate them. I believe this last point has now become the de facto standard, where people more and more relinquish control to foundation models. Just don't forget to evaluate on realistic data before you scale to keep your users safe. So before talking about how to obtain representative data, I'll sum this section with what's obvious in retrospect. The other side is also a user. Meet them where they are and expect zero adaptation from them. While some products like smart home speakers can afford to train their users how to talk to them, we actually need to train our machines to talk to users. So I probably don't need to motivate too much why a good representative corpus is critical for success, for training, tuning, and evaluation, and to make product decisions as discussed above. It turns out that there are no great corpora for real spoken human-to-human conversations, where the two sides work together to accomplish something pragmatically. And you can compare this to podcasts, audio guides, movies which are abundant. And we found that external corpora can only go so far in teaching us how to actually talk to people to be effective and pleasant. This is even more true when looking for data specific to how your product will perform. The special characteristic of dialogue with real humans also makes data acquisition inherently expensive if you count on just talking to real humans a lot, and moreover has important privacy implications, as we will not just record people we talk to without their permission. So the first advice here is to resist the temptation to make shortcuts and rely on intuition just because data is hard to obtain. Plan your data needs, which type, how much, and how you will get it. Build data needs into your project timeline. A standard principle when building ML-based products is to not only be great when you work well, we should also be reasonable when we don't work that well. So some users will be okay with trying it out, even at marginal value. So over time, we will get the data we need to hill climb to excellence. This is akin to how, unlike a car that is just manufactured complete, a baby is born with enough capabilities to somehow survive until it learns to walk. To facilitate this, we need a combination of technology to provide decent quality at day one, and UX, reducing the cost of errors and providing graceful degradation to an established pre-existing baseline. For example, when developing Hold For Me, a pixel feature which listens to hold music for you, in the early days of internal user testing, we made sure to tune our models to more aggressively prefer false positives to false negatives, because dropping a call after a long hold is not acceptable. As we gradually expand our user base from internal testers to external to beta and so on, we get the data we need to improve quality and then afford to expand to an audience with higher expectations. But sometimes we can't even reach decent quality without seeing realistic tasks from real users. In this case, we can't bootstrap the above process because even the early adopters won't use the product unless you guarantee sufficient quality. For example, when we developed our first application of booking tables at restaurants, we could not afford to make wrong reservations and send people at the wrong time. Also remember that since we are talking about products that actually talk to someone else for you, even if you are a tester that is aware of and happy with the risk of a new product, the other person may be just someone picking up the phone somewhere. And as we said, they are also a user. We should guarantee they get good experience and we provide them real value. So another solution for lowering the cost of error is to ramp up over automation instead of over quality. That is, we guarantee a product always works well by teaching the bot to ask for help when it's not sure. While in the early days, the bot may ask for help so often that the feature's value add is marginal, it's usable and pays off over time as means to get the data to improve. Of course, while real organic usage is the best kind of data, it is the most difficult to obtain, both pragmatically and from a privacy perspective. if the primary principle here is to practice over low-cost errors, to be data efficient, we can still generate a lot of realistic, non-organic data for training, data augmentation, and tuning and evaluation. Since the core of the problem is that obtaining data requires talking to people to see how they react to what we say and how we react to what they say, the two solutions we've employed are actually hiring vendors to talk to our bots and train them, and simulate human behavior using a partner model. Of course, both of these solutions have the disadvantage that they might not really be reflective of how people really behave in realistic situations. Usually, both vendors and ML models tend to do what you train them to, more or less, so they provide limited signal from an information theoretical perspective. However, when training them with a horizontal enough guideline and evaluating on unseen tasks, we can regularize the signal and actually learn horizontal behavior. Specifically, the simulated approach has become orders of magnitude more effective in recent years, where today using LLMs to generate realistic human behavior with a given flavor, like try to be rude and impatient, is often not only cheaper and quicker, but also higher quality than using vendors, because LLMs are culturally aware and can creatively think of edge cases. This provides us with cheap and effective data for both training and evaluation of products at early stages. I'll note that this application of a model for the other side is different from the concept of generative adversarial networks. The models are not adversarial, as they do not compete. They actually work together, and the models are not trained together. All of the example methods that I showed here follow the same general principle. Find access to ramp up over that will minimize the cost of error while your product is still a baby, until it learns to walk. Transparency. Transparency is always an important principle by itself, but in our case, it's also critical for pure product usability. It is inherently difficult to delegate tasks, even to a competent agent. You need to trust that the agent understands what you want done, will get the task done as best possible in the face of unexpected circumstances, and then trust its reported outcome. And of course, if you hand over personal details or permission to perform actions for you, you need to trust the agent will not do anything unintended too. It's obvious that trust depends on competency, so if you disappoint users by failing, they will not trust you again. But competency is not enough. What we've found is that in order to meet users' expectations, we must be very transparent about everything we intend to do before taking a task, everything we're doing while performing it, and what happened when we report the outcome, where quoting authentic references both increases robustness and inspires trust. There's an obvious trade-off here with flooding the user with information that would dilute the value or magic of the product. So the standard solution is to make details available to check but not required. This allows new or suspecting users to verify us, but over time, as users learn to trust us, they would stop checking. It just helps to know the reference is there if you ever want to check. So before talking to someone for you, we should be clear about what we're planning to do for you, who we are about to contact, and what is within our permitted power to do on your behalf, and information about it that we're allowed to share. In fact, I would even emphasize, it's important to explain that we're actually going to talk to someone on your behalf. One of the things we've seen is that if we try to simplify the user's mental model by looking like an opaque action that just calls someone behind the scenes, we end up not really simplifying, but creating a wrong user mental model with wrong expectation. Except for demos, magic is less important than clarity. We've seen examples of product changes that, even if actually reducing the value created for users because we do less for them, hugely increase CSAT and retention because we more reliably do what we do promise. On that note, another thing we can do before accepting a task is giving users a good estimate of what we expect might happen, based on a lot of statistical data that we have from having talked to so many people already. For example, if you're trying to call a busy restaurant at peak hours, we can warn you that they often take more than an hour to pick up at this time, and are pretty unlikely to have a table available, and so on. The same principle applies throughout. Clarity is more important than magic. Show your user what's going on, so they know what to expect. They value what you do for them, and it will even reduce the severeness of failure. So we touched upon some important tips for deploying conversational AI at scale to talk to others for you. Thinking of both sides as users and tapping into existing frameworks, collecting and heavily relying on actual conversational data by ramping over low-cost errors, and being very transparent about what your product actually does. As for the future, as technology becomes more and more easy and effortless to talk to, not only can we communicate with technology easily ourselves, but we can automate everything that requires communication with others when we can't or don't want to talk ourselves. As everyone implement natural sounding agents on all sides, we might talk to machines more like people and maybe talk to some people more like machines, and even machines start talking to each other using free language, which is a universal protocol. And while talking to other people can sometimes be fun and fulfilling when the goal is the human communication itself, there are also so many cases where it isn't so fun and does not feel like time well spent, such as talking to customer service or taking an unknown call while in a meeting just to tell the delivery guy to leave it by the door. And by deploying this at scale into every journey that involves communications today, I think soon you will never have to talk over the phone. So you'll have more time for the communication that you actually do want to have. Thank you.